very talented individual. I was just looking forward for greatness from him, because the reality is, as we all know from a fact, there is a lot of talents here in Jamaica, and we do want to of course encourage each and every one of us to seize that opportunity to of course share your talent and to create wonderful solutions, or to be able to test solutions, because I know we also have some QAs in the building. I know we have some um, persons who are developers, we have some project managers, etc. So regardless of whichever field that you're in, there is something great that you can be adding to the profession. I'm definitely looking forward to each and every one of us adding to the profession, because of course there is some amount of idea that Jamaicans are not that great at developing wonderful things, and we're definitely going to dispel that information, because that's not accurate, right? Great. So, for today's session, we'll be looking at leveraging multimodals to make predictions. And who doesn't want to make predictions? I mean, if it is that we were able to predict COVID was coming, then of course we could have maybe sold some stocks, or perhaps bought masks, invested in some companies to buy masks or make masks. And then, of course, during the COVID period, you essentially become very wealthy. So the reality is, there's data out there that we can use, and systems that we can consume those data to make some prediction. And we're definitely looking forward to that. It may not necessarily be something so phenomenal, like predicting the next COVID event or what to do, but we're definitely looking forward to more information. I won't give you too much detail as it relates to what he's going to be presenting on. All right. So, just a little bit about the community. We are the Jamaican Developers Community, and we also do activities under the name Caribbean Tech Connect, because the reality is we're trying to build, the career, build the profession, create linkages between employers and employees, create linkages between different tech organizations, etc., and essentially building the skills of not only just persons in Jamaica, but of course the Caribbean, which is one of the reasons why we have the name Caribbean Tech Connect, right? And but of course, we're all one family. We simply trade under a subsidiary, depending on who it is that we're doing activities with. Because there are times that we do activities with persons outside of Jamaica. So, during those contexts, from time to time, you may see the name Caribbean Tech Connect, but it's still us, still the Jamaican developers community. And this is essentially our objective: build and market our skills, right? We're going to learn and share the knowledge, because knowledge is important, and it cannot be that we have this great knowledge and we're not able to share it. If it is that someone can develop or improve on that knowledge, they won't be able to do that if it is not shared. And the reality is, even with the seatbelt, for example, that it was only one man's idea and he simply shared it, and no seatbelts are in every car that allow each and every one of us to be protected in the event of an accident, so that we're not thrown from a vehicle. So the reality is, sharing knowledge can be very, very impactful, and it gives persons an opportunity to not start from scratch, but essentially start on a foundation, a great foundation, and improve from there, right? But of course, this also gives us an opportunity to provide help to each other, whether it is online and in person. So we do have the Telegram group. We do have a channel on WhatsApp, etc., where it is that you can interact with us. Maybe you're just learning to develop, maybe you're just learning or transitioning to a QA role. Essentially, there are persons who are within the field, who are in these groups, that you can always message, reach out for help. Maybe there's something that you're not sure about, or perhaps you've wanted to improve on a particular language or framework. This is an opportunity where you can, get online help or in person. Because from time to time we do meet in person, sorry. And even the last in-person meeting that we had there was one of the members of the community who was starting her business, and she was able to get great insight from someone who was already in the tech space, who has started several businesses. So it's really an opportunity for us to foster and help each other to grow, and of course create a positive impact, because at the core of computer science is problem solving. And we definitely have a lot of problems that we want to solve out there, right? So looking forward to greatness from each and every one of you guys. Right. So there are many problems, as I said before. Some of it include companies not able to find developers, not able to find UI UX practitioners, not able to find data scientists. So we are essentially creating a pool of resources that allow companies to be able to find and recruit, talented individuals like yourselves. Now, developers may not also have the skills sometimes, and they may not have the expertise or the experience. And from time to time, we actually do have persons volunteering with us, employed, to work with us to create solutions. And there are times when we even mentor persons to have them continue to grow, and develop their skills and experience. We even currently have some persons, just transitioning into university, and based on just the different projects that we've put them on, we've seen phenomenal growth. And we definitely want to encourage all of that, skills and growing and experience and building that portfolio, because you don't necessarily have to finish your degree to start building and your skills and experience, through communities like ours. We do try find avenues to build those skills and experiences, etc. All right. Now, for today's agenda, we'll be, doing our we've been doing the discussion so far about, the community, what it is that we do, some of the, ways that we are involved in the different fields, whether it is project management, whether it is animation, whether it is UI UX. We are definitely involved, and we look forward to, you know, being involved and you being involved to, benefit from the community. So we've done that discussion. I'm going to be introducing our speaker, after which we'll hand over to our speaker to allow him to do his presentation. And then, of course, we'll be doing some amount of discussion again, some upcoming events and some past events. If it is that you've, missed out on any of our events, and, we're going to give you a little sneak peek of some of those events that you've missed out. And of course, we'll wrap up and before the wrap up, of course, allow you guys to interact with our speaker. All right. So if it is that you have any questions, you can jot them down, and we'll get to them after the presentation. All right. So Jordan Barnett, right? Now, this fellow is very passionate about data, right? Jordan has been a senior data engineer in a leading fintech company specializing in large language models, LLMs, since 2020. His journey began in OpenAI Playground, where he first explored the capabilities of AI and its potential, to impact finance and all areas of life. So we definitely want to see how it is that you can use, large language models, or we can use AI to help make some prediction. Without further ado, I'd like to hand over now to our speaker. Jordan, are you ready?
Yeah, thanks, man. Let me just share my
All
screen.
right, over to you. All right.
I think you should be able to see it just fine.
Yes, you're sharing successfully. Great.
Yeah, so thanks for the warm introduction. So right now, I want to talk a bit about applying multimodal models in home price prediction. So when Alvin was talking about prediction, he was kind of referring to like, taking like a time series data set and kind of like figuring out like what happens next. But when I'm discussing prediction in this case, it's taking like a bundle of features or like characteristics for a given property and figuring out like what the ideal price would be based on how those features have corresponded with home prices previously records. So it's a bit different. It's not like a time series kind of thing, although you can use it for time series to kind of predict like how average home prices might change in the future. So I just kind of want to give like some clarification on that. And it's for multimodal models, and I'll kind of specify like what that means a bit further in the presentation. So in terms of an agenda, I can first like give like a summary of the project. I'll go into like general survey of like generative AI use cases, and then I'll get into like further details, and we might wrap it up with an interactive demo. Cool. So the problem, what I want to accomplish, like I was alluding to a bit earlier, is taking like a given set of features for a given property, like the number of bedrooms, number of bathrooms, what community it's located in, and figuring out like what the price is or the value is for that property. Now, why I want to do that is a bit more philosophical, maybe. But generally, that would be something interesting to do because you could technically figure out like arbitrage opportunities, specifically like mispricings for a given property. So say it's in an area that there have been like many listings. If I can like better price a property than like a valuator and I buy it, then there's like a good amount of or a good chunk of profit that I could make on that theoretically. So that's what kind of makes it interesting. So when I say the price, what I'm actually trying to predict is the listing price, not necessarily the sale price. That should raise some alarm bells for you because those are two different variables. However, in terms of their relationship, it's actually quite close. So a friend of mine would have provided me with like 1,000 listings and their corresponding sale prices. So I did like just like a quick analysis to confirm that, hey, listing price and sale price are pretty tightly correlated. So we can, with some confidence, about 3.2% error rate, use the sale or the listing price to predict the sale price. So it's okay if we predict the listing price. I'm comfortable with that. Okay, going further. So the data. So we have about 9,000 residential property listings, and it was sourced ethically from publicly accessible agencies and providers of listing data. And like I mentioned before, it's not including a sale price. I just want to bring that home. So in terms of the categorical data, we have like the parish, the community, the type of property being an apartment, a townhouse, or a regular standalone home. Whether it has a garage or not, it has a swimming pool, if it's gated. Because when I say swimming pool and gated, those are like yes, no. So they're binary, so they're categorical variables. In terms of numeric data, we have the lot size, the building size, the bathrooms, the bedrooms. And we have day index. Day index is a bit interesting. We kind of want to, when I mentioned earlier that we can technically predict average home prices in the future, this is what I meant. So you'll see like a slight trend since the data spans like multiple years, I think since like 2020. You see like a slight uptick like as the years go on, that the average home prices without any kind of feature changes. Oh, there's a question. If the sale price has, I'm going to, I'm not going to read the chat until I'm done. I'm getting slightly distracted. But that's a good that's interesting commentary. I won't get into that though. So what we can do is we can use that trend and kind of remove it from how it might alter like a given home's valuation. So we can like use a home listed in like 2023 as part of our training set for like homes that are like 2021, 2022, and 2024. because we've like removed the influence of like inflation or just like general property price appreciation. And we can like bump up the day index, for instance, to like 5,000, right? To see like theoretically what home prices might look like in the future, given that homes are looking about the same. Um, what we have here are a few distribution charts. So first we have homes by parish. And I think something should really stand out to you guys, which is like most of these are in Kingston and St. Andrew. So there's like a major case of like class imbalance going on. And this gets uglier as we keep going, but it's okay. We can still work with it. We also see that in terms of homes by property type, it's largely just like regular single family homes. However, if I were to dig a bit deeper, what you'd find is that basically all the apartments are in Kingston. So you have class imbalance in terms of like where the homes are located, and also that the property mix changes drastically, like in Kingston versus like anywhere else. So that has some like interesting consequences down the line. Methodology. So I used for the home price prediction, I would have tested like XG boost and linear regression, but I found that the random forest model was the best for this use case. And it's a good model generally, especially like for like a quick and dirty bit of like prediction, because and especially in like our case, because it's robust to outliers, it's robust to missing data, it's simple to train and fine tune, and it's generally pretty performant. And these features like robust to outliers and robust to missing data are typically common in like decision tree models, but this one is pretty well supported, and it worked pretty well. Cool. So now I kind of want to step away from like regular ML talk into something a bit more novel, which is like generative AI and its use cases. So what we've commonly seen, I'm sure like you've seen people use it for like text summarization, translation, retrieval augmented generation, which is like you have like a bunch of documents and like you have like a generic search and it uses those documents to answer that question. Classification, which is what we're doing right now, and writing your code for you, which is what everybody uses it for. But we're kind of honing it on classification. So why would we use generative AI for classification? Well, it's a good question because there are, technically speaking, more refined or specific models that we could use. But there are a few benefits for using generative AI. First of all, it's a low time investment, meaning like you can really get something that works pretty well up and running like a day. It's pretty generalizable, like which is a feature of most LLMs or multimodal models. What's most important is that it can simulate human level like reasoning. But more importantly, what we want to simulate is taste. Specifically aesthetic values. And you'll see that show up a bit later. And it's good for zero shot classification. When I say zero shot classification, what I mean is like without giving it any kind of like training, post like regular training of the model, you can like provide it with a given record and it can classify it for you, like without having seen it before. Like again, like the generalizability comes into play for that. Also, it's ideal for data scarce applications. Again, because there's zero shot classification, if you don't have like a substantial enough data set to do like significant training, like you have like a couple hundred records or like low thousands, it's ideal. Because you don't have to like sacrifice some like the training data set to get like a good model. Yeah, and again, it's just easy. Easy is the general benefit for using generative AI in this scenario. Easy and it's human-like, which you shouldn't discount. Classification, right. So when I say that you can use it for classification, I kind of want to start off like a very simple example. And I thought this was really cool. So if you've like read property listings before, what what you might notice is that like sometimes they'll mention like a home is like a fixer-upper or like it wants to be restored. And these are like fuzzy concepts that like typically you'd want to use like a regular expression or just like a typical string, like to search for these to kind of figure out like, hey, this listing needs a repair or not. But you can't, that's fuzzy. Like you can't even use fuzzy search for that because the terms vary so much, description by description. So what's really cool is that you can just ask like an LLM, like, hey, based on this description, does it actually require repair? And it can do that for you. So what you're seeing right here is a plot I did to show like the difference in like the impact of repairs required classification and price. And we can see actually is that, hey, those homes that require repairs, you know, have a lower price on average than those that don't. So it's cool I picked that up from the data set. Interesting. So multimodality. So when I mention multimodality, the example I gave before would have been like you know, the standard LLM use case where it's like text in, text out. But when I mention multimodality, what I'm referring to is like different types of media that you can pass and receive from a model effectively. So you can have text, images, audio, video. Gemini has video. And this is useful because we're going to be working with pictures. So there are, this is pretty outdated. I think I made this presentation at the end of last year, but there are a lot more now. But in the closed AI camp, you have like OpenAI, Anthropic, Gemini, open source. Obviously, that have to include like DeepSeek now. We have Llama, Quen. Like those are pretty good places to start in the closed versus open source camp if you want to like work with multimodal capable models. I've found that in terms of the stand-up time, you probably want to start closed, and then if you find it works pretty well for your use case, can stand up your own infrastructure and play around with the open source stuff. Yeah, cool. So why it's useful to have multimodal models is because we want to incorporate visual features from a given property listing into the price prediction. So I give like an example here where we can actually overvalue based on non-visual features. So we have this property where it's like it's in Nain, it has 3 bedrooms and 3 bathrooms, 1,200 square feet. The lot is 9,700 square feet. It does require repairs, but overall, the price is overestimated because based on this, there's no kind of indication of like how when you say it requires repairs, like it's just a roof. No, it's like it's actually unfinished. So and you can't glean that from just like the description or you know, the features that they might list. You need to actually look at it. What might be like really easy for us is not so simple or trivial for a model. So when we actually incorporate the visual features, we see that the estimated price, you know, the prediction is much better. So before we're predicting it to be like $31 million, and actual price was 18,900,000, which is like 65% off. But when we actually incorporate this visual quality score of 2 on a 10-point scale, we see that the estimated price drops like way down. It's like 20 million. So that's not so bad. It's less disastrous than overshooting by almost double. So the new feature, what it's actually called in the data set, is a luxury level. And basically you can like imagine a 1, well, this is a 2. So you can imagine a 1 is basically like a shack. And then 10 would be like a Bel Air mansion. Can yeah, that should be a 10 from the range that we can be expecting. I can go into kind of like how this works. Somebody wants to put that in, I think. In terms of the algorithm, so basically for each property, I would fetch like the first 5 images from the listing, convert them to base 64, and then you know, basically ask the model, hey, based on these images, how you know, how aesthetically pleasing is this property? And then we've mapped those scores back to the original listings to add it to our data set. So this is the the API call, the full one. Well, this is a JSON schema. So this is important because it gets really annoying if you don't specify a JSON schema because you have to like additional parsing on the LLM output. So you want to kind of like scenarios like this where you have like a couple thousand records to go through. Like you don't want to like have any surprises. You want to just conform to a given structure. And this makes it like really easy to work on like batch problems. So we have the schema called visual property analysis. And then we have a few properties. The first one that you might notice is classification reasoning. And this is actually to ground the model. It's actually to ground the model. So we give a description, hey, we want 1 to 2 short sentences with notes from the pictures that would factor into your final score. So what we're trying to do here is kind of like say, these are not supposed to be arbitrary. You should have some kind of justification for giving it like a 1 or 3. And it gives it some time as well to kind of figure out the number. Then we have the luxury level, which is what we end up using, which again is just like 1 being the lowest, 10 being the highest. Just give it something in that range. We also specify it as an integer, so ensure it doesn't like say 1. And we have home tier, which we use an enum for, and this is low end, mid range, and luxury. So I had home tier in here because I didn't actually know like which feature would perform better, like something more granular like luxury level, which is like 10 options, or home tier, which is like just 3. So I wanted to get some variety in there and play around with it. And we have strict true to ensure it doesn't vary. Cool. So that's a schema that we passed to ensure that the model provide the same result structure for every single call that we made. There's a couple thousand of them. Cool. And now this is like the actual result. So what we can see is like this is all like by level. We have starting from 2 all the way up to 9. I think it got to 1 and 10. But you kind of generally see that it has an idea of like what a low aesthetic value would be. I roughly agree with the 2, the 3, the 4. What I found is that it kind of underperformed in like the 5s and the 6s, or like 4 to 7. Like, but I wouldn't knock it too much because what I was really worried about is like a really bad home kind of sneaking its way in and like being overvalued, and it does capture those, so I'm okay with it. Now this is the juicy part. So the actual like correlation analysis. So luxury level actually turned out to be like a pretty strong feature in terms of like how well it correlated with like actual price. So this is this is pretty nice. We see like a staircase that hey look, like homes with like a luxury score of 1 obviously should have like a low value. As you get up to 9, the variance like goes crazy. I would say it's like property values skyrocket. So this is actually what I was expecting to see. I'm happy. I was really happy when I saw this. In the correlation heat map. So what we found is that luxury level actually had the highest correlation with price out of all other features. So bathrooms was 0.41, yeah, with price, but luxury was actually 0.58. So that's like really significant. That made me pretty happy. I also didn't correlate that strongly with any other feature except for bathrooms. It correlates pretty strongly with bathrooms because bathrooms correlate strong with price. Yeah. Now, in terms of actual predictive power of the model, like once I incorporated the luxury level, I think I just ran like a prediction like with only like luxury level in there to see how well it predict the price. I got the R squared of 0.34, which is not good, but that's roughly what you'd expect if you have like a 1 feature model. So it's not that bad. When we incorporate it like with the other features, what we found is that it actually was pretty important. The third most significant feature when we predict the property price, like right after like, the bathrooms and the size of the property, which is like really significant. So this is like just like a breakdown plot that shows like the significance of each feature in determining the final price for a given home record. So the results, right? The results were, I'd say, instructive. That's the word I give it. So we have an R squared of 78.62% for the overall model, which is not that bad. The median percentage error rate across like all properties was 13.86%. Meaning that like for the median home, you can expect about like a 13% error rate. However, like when we go to like Kingston and St. Andrew, what we found is that the error rate was like a bit lower at like 10%. And that's again from what I mentioned earlier that like Kingston was like really overrepresented in the data set. So you would actually expect like performance to be better there. The parish that performed the worst was Portland, and I think it's because it's like low hundreds of properties, so not much variation to accurately figure out like how those features would have affected like the price. And the class of property which the model was most accurate was apartments. And like I mentioned, in Kingston, apartments were the majority of the listings. And for that, we got like a 8.39%. For some context, if we were to compare this with Zillow, Zillow would blow us out to the park. Zillow has a median error rate of about 2.5%, I think. So it's like crazy good. But you know, Zillow also has a lot more resources, a lot more records of data. So potential areas for improvement. Like how could I, you know, if I could like, how could I kind of get it closer to like the benchmark, like Zestimate? Fine tuning is one option. So what I did is I actually created like a small data set of about 100 properties, and I would have labeled them like in terms of like how I um would rate it aesthetically, and that should roughly improve you know how well the model can like figure out like how a human would rate the aesthetic value. Um Evals, I'll get to that last. Historical transaction data. This one is a big one. So I don't have access to the historical data for like a given like community. I think that could like really ground it. So if like you look up the methodology for like how this estimate is calculated, they actually use or incorporate like historical sales a lot in their model. And I think replicating that would be nice. The data is there, it's just behind a paywall. Uh and evals. So in terms of evaluations, um, what I'd probably do is like similar to fine tuning, just have like a couple low hundreds or like 100 properties, and just kind of specify like, hey, I'm expecting this score for this, and try to minimize the the discrepancy between my score and the model score. So it's a bit different than it's like a part of fine tuning, you could call it, but it's a bit more involved. Cool. And this evals would be good to test across models actually. That's where it would be ideal because I wanted to better compare how like Haiku from Claude was performing. Um yeah, it's not a closely guarded secret. You can access it from Jamprop sales actually. You can buy it. It's like 90 grand. I don't know how far back that Jamprop sales goes though, but yeah. I won't touch on this too much because it's political. Um, so evals like to compare between the models. That would be nice. Because I did want to like use like Gemini and Haiku, and then see how that compared to GPT o1 mini, or not o1 mini, GPT 4o mini. But all I had to go off of basically was the R squared, which is not ideal because that's like after I've run like the whole data sets through the models. So I can't quickly spot like any shortcomings for a given model or any biases that it might have. References. I kind of want to take a second to go through these. So the BOJ did like some pretty interesting work that would have influenced some of what I would have done. So they have a hedonic residential real estate index by Jamaica. So it was a pass. It was just for Kingston and St. Andrew, but it's interesting reading. I'd encourage anybody interested in Jamaican real estate to give that a look. Exploratory model analysis for like the breakdown plots and kind of evaluating the regression model was very helpful for that. I'll skip past these two because they're just textbooks. For general like how to like interface with OpenAI, I always recommend the cookbook. I hope they're still maintaining it. At one point it was like ideal, but what I recommend actually is skipping the website and just go straight to the GitHub repo because the examples there are, you know, much more coherent and GitHub search is okay. In terms of like inspiration and like incorporating the visual features, would be these two papers. So they did it a bit different. They used, if I'm getting this right, they would have used like CNNs, and incorporated it into like a ridge regression model. So it's a bit different from what I did, but like in terms of like grounding or like figuring out like, hey, this would actually be like useful. These two papers were pretty helpful. Also as like benchmarks to like compare my performance against. And these two papers are related, 1 and 8, constructing residential real estate price indices for Jamaica. So I just recommend these two because they're just interesting and you know I feel like they're not very well known. The BOJ has like an archive of all the research that they've done and they have some pretty interesting data in there, and analysis. So I would encourage anybody interested in general like finance or econ to give that a brief read. Cool. So I kind of wanted to go into a guided demo. There is a link that should be shared in the chat. If it's not, I can send it again. But this is a Google Colab link, and this is like if you want to replicate something like what I've done, which is like incorporating LLMs into like any prediction area. You can basically just like copy and paste the code from here, or you can feed it into like an LLM to give you like new ideas. So what you would need is you would need an OpenAI account, or if you don't want to actually, or if you don't want to actually run the, if you don't actually want to run the data through like your API, the API and like spend $5, then you can just like download the inference results from this Google Drive URL. And these are both publicly accessible. I'll just post the link after I'm done. I'll make sure I post it. So this is an Airbnb listing data set. I just kind of want to lower your expectations. The results are not as phenomenal as they were for my data, but this is just kind of quick and dirty, and it's mostly just like an example. Right. So we have Airbnb data, and well, we have a lot of features. I'm going to ignore most of this and kind of just like get into the nitty-gritties of it. But if you kind of want to look at it, there's like the listing ID, the reviewer, the reviewer name, comments about the property. And we also have the listing price, like the weekly price, the monthly price, security deposit, cleaning fee. These are the important money-related columns. Post response rate. So it's kind of just figuring like what would be like interesting to try and predict. Review score distribution. So the two variables we try to predict are like the reviews as well as like the listing price. Yeah, that's a URL that was just posted in the chat for this Colab notebook. And you can run it for free, by the way. The Colab you can run for free. The actual like API stuff you would need to pay for if you choose that. So this is like the review score distribution. And this already kind of annoyed me because it's like all highly reviewed. Like, and if you use Airbnb, you would notice that like basically like, all the reviews are going to be like perfect. And you see this on like most like rideshare applications or like anything that's like community driven. Typically, you'll see like a distribution like this, but that harms us because we can't very clearly distinguish what would make a really good rating from like an okay rating. Because like if it's okay, it's 100. It has to be like pretty bad to get anything lower. The price distributions. This is interesting. This is for files like a roughly normal distribution. And this is an interesting thing to try and predict a listing price from like different factors or features in a listing. And we see like what might affect or like the price distribution per property type. Yeah, I'm going to skip past this. I encourage you to survey it if it's interesting to you. But it's just download from Kaggle. Skipping this. So what I'm interested in is just like a base prediction of like, hey, we take these numeric features like the bedrooms, the bathrooms, how much it accommodates, security deposit, all of this, and can we predict the price? And yeah, kind of. So we get like an okay, R square of like 0.62, which is like, all right. This looks like if somebody were to spend a lot of time on it, they could probably improve the performance of this model. The mean absolute percentage error is like really high though, 0.27. If you recall, my median was like 0.13. Yeah. Um, right. And we can select the important variables, which is like bedrooms. Again, like you'll see this, like bedrooms and bathrooms are like pretty strong predictors of the value, be it rental or like sale of like any property, obviously. Um, but what we want to do first pass is like, how can we replicate what I did for Jamaican properties for this, which is like using the listing images to get like a qualitative aesthetic score and see if like it actually factors into the listing price. Same, it's roughly the same code that I would have used, which is like encoding the image, getting property images, displaying them like when we're done, displaying like the grid that you'd have seen at the end of the last presentation. Skip this step if you've already downloaded the inference output. Like I mentioned here, if you don't want to spend money and add your OpenAI API key, then I recommend that you just download these Google Drive files, dump them into the folder here, and you can like continue um without actually having to spend money. Yeah, cool. But this is like the same schema that I would have used previously, which is like visual property analysis. So like literally like the same code. We loop through each of the images and we ask, hey, can you analyze the properties per perceived value slash luxury level? Like just from giving it like 5 images basically. And what we see is that here's an example like of one of the images. So the reasoning image shows a well-lit dining area with a modern glass table, pleasant view of greenery, suggesting a comfortable living space. And it gives it like a 5. I'd give it a 5 as well. I don't have many opinions on this property. It looks pretty average. And then we can run it across all of them. Some don't have images, but that's okay. And then we get, a general survey of like the homes. So we have like the home tier, low end, luxury, mid range. I roughly agree with these categories. Yeah. So I didn't do it by luxury level for this, I guess, for in terms of grade. Probably because it was like annoying to like get all the images like in one place. So the count of home tiers. So mid range, luxury, low end. So as you'd expect, mid range would like have the most properties in there just by being in the middle. But this is not as nice as my Jamaican data. You might notice the stair step effect is not as pronounced. Like ones and twos are a bit different. Like twos are actually lower price than one. And this is where like evals or fine tuning would actually like improve this a lot, I'm pretty sure. But it's a demo. It's just like a demo for like code to go through. But yeah, this is not good. You don't want to see this. You want to see like a nice stair um stair step, like where like 1 to 10 or 9, it's just evenly up and to the right. We see mid-range, luxury, and low-end showing roughly what we'd expect though, where low-end properties do have lower prices than mid-range or luxury. And we see price versus luxury level here. Yeah, again, this is roughly the same thing as we saw before. Cool. So when we try to incorporate these visual features, what do we get? We get a score that's roughly the same. So we get 0.622 and the mean absolute percentage error is roughly the same, 0.27. So it did basically nothing. Like it's just like noise effectively is what the model output is telling us. But I didn't give up. I wanted to actually have some result for this interactive demo. So what we tried next is actually like figuring out if the reviews could impact the prices. So like, hey, it's not giving a very good review. Or like if you remember, if you scroll all the way to the top, the review scores were all like hundreds. There's no like there's not enough granularity here. So what we want to do is take the actual reviews, like the text reviews, and kind of figure out like, is this actually a 10 based on what they're saying? Like they're sound really excited about the place, or is it actually like an 8 or a 7? So we're deriving like a new review score effectively to use for like price prediction. For this, I use 3.5 turbo. Did I? No, I didn't use 3.5 turbo. I just wanted to get the count of tokens, which is like 7 million tokens. Not so much actually. This is it's pretty cheap with today's model prices. So yeah, about 7 million tokens in the entire data set if you choose to run it. So yeah, we're just asking, hey, based on the review text, which would be like here, the comments, what actually is the score that you give it? And it can be categorized as well, negative, neutral, positive, very positive. And also like we want like a 1 to 10 effectively for the score. And we kind of like want to give some more granularity to the reviews. Cool. So when we do this review analysis, I think why yeah, so this is the original distribution of review scores, and then when we have our synthetic review scores, it's a lot nicer this way. This huge bar, I need to dig further into, but you can almost, if you squint, you can kind of see a bell in this versus here. So I prefer this feature, and this is what I'm going to use to try and predict the price. Not much variance between like the category and the price. Like I can't see any kind of discernible difference here. However, there kind of is something when we use review score. And we can kind of see how it looks when we actually incorporate it into the model. So we add like review score as in the set of numeric features, and we actually get a 2 point lift in the R squared, 0.64 now instead of 0.622 before. So that's awesome. Maybe if we did this a bit more refined, we could get this a bit higher. So I'm pretty happy with that. And the idea is not bad. Cool. Yeah, and this is the regression plot. So I would encourage you if you think that you can, I think you should be able to improve the scores. You should be able to, because I did nothing effectively in deriving them. So see if you can get like a 0.7. You should be able to get a 0.7. This is actually not a bad place to start from. I think in my data set I was starting from like a 0.5. So this is like good. This is a good starting place. I'd encourage you to play around with it if this is something that interests you, or you can apply the code in your own application if it so suits you. Yeah, that'll be everything. That's roughly everything. So if you guys have any questions, feel free to ask. Um, cool. I'll be quiet for a second as any questions pop up.
Okay, thank you so much, Jordan. All right, so guys, I know this was very impactful in terms of the different ways in which this is a bit almost like a step up from just the regular large language models, based on the fact that it can incorporate visual and other data into the information, so that it can the AI can actually make this decision. So if it is that there's any questions, if it is that there is any area that you'd like him to maybe do a little recap on, now is an opportunity. The floor is open. All right, and we see where he has also made the link available, so you can also try out some of the features to play around with this project. All right, right. So
And the possibility exists as well that the presentation could have been of like such high quality that no questions are left or remaining. So I'm also happy with that.
Oh,
Um,
okay.
I'm fine with that as well. If there
No,
aren't.
no, no problem. But if it is that you're maybe a little lost, there are some other of our sessions that we've done with a more basic run through of large language models and AI, and you making predictions, etc., and training your tool to make great decisions, or to perform accurately. So you can always feel free to check out some of those information um, that we have available to you, some of those resources. All right.
Yeah. So that's
So go ahead.
Oh, I was just reading from the chat. So Jeff asked if I could explain again how the scoring on the images for the luxury ratings were established. Right, yeah. So I kind of go back from like the algorithm, which is very straightforward. So like for each record in our data set, we'd have like a URL to the listing, and then I just pluck 5 images from that listing URL, and that's what I'd feed to the LLM in terms as part of the prompt. So the prompt is basically composed of just a simple query. Can you analyze this property's perceived value? five um 5 listings or 5 listing images, as well as the schema, which defines like how I want the response to look, which is the luxury level where I describe that, hey, I want a visual quality score from 1 to 10 based on the query that I provided you. Um so I hope that my answer. So basically, like for every single record in my data set of like 9,000 records, everyone that would have had like an image available or like a URL with images available, I take 5 images. So it's like 5 times 9, that's 45,000 images that I've fed, 5 at a time, to the OpenAI API. And I've gotten like a score for that unique record to assign back to the property. I
Right.
hope that's a okay
Right.
explanation.
So just to underline, because if you recall, there, houses are gonna be priced, and placed on the internet. However, there are times when, just it being priced at a whatever point that is, it doesn't truly give us a good understanding of if this is a good price, based on the fact that, one of the things that he was saying, is it a fixer upper, etc. So with the image being able to add to that level of, to say, yeah man, it should be rated around this, or should be rated a little less based on the amount of damages to the property, etc. So essentially he's trying to incorporate more data to give a more accurate, for lack of a better word, valuation. It's not a valuation he's doing, but almost predicting how much this could be sold for. So, you may not necessarily have the ability to visit all the properties that caught your attention. So, using his tool, you could maybe, look at more meaningful decisions coming from it, to not select every property, but the ones that are more in line with your price, and what is left to be fixed on it, if any at all. So I hope it does clear up the understanding. but
Yeah.
but it was clear for me. you know so do feel free to post your questions. I do see some of the comments that say, hey, the presentation was great, very interesting. They're just going through the information, and trying to consume it, and seeing how they can apply it to other situations. So yeah man, that's fine. We definitely want to encourage it. That's what we're here about, sharing the knowledge, and of course solving problems, because this is a very practical way of using AI. The reality is, many of us, we're looking forward to owning that home. We may be trying to find somewhere to purchase right now. So, this, we're seeing how we can easily use tools that are readily available to us to help us make decisions as it relates to what it is that we want. So, very practical. very practical use of the tool. All right,
Um,
let's see if we have more questions. Go ahead.
yeah, so Shane asked a question if the model incorporates location. It does. It does. So we have two location features, which are the parish and the community. One feature I did play around with was like the distance from a beach or like the distance from the coast. I can't remember if that made its way into the final model, but yeah, it does, and it does also have like a urban rural differentiator variable as well. And tourist regions. Yes, the tourist regions do have more luxury homes. So like if you look at like Mobe, you find like a lot more luxury than in other parishes, for instance. That's a good guess. Mobe and actually Saint Anne, yeah, Saint like a lot of luxury listings there. And to account for like appreciation over an extended period of time, like I mentioned, like we have like this day index, which kind of detrends the data. So you know, listings from like one time period are comparable to like listings from another.
Right. So, and the reality is, this is a tool that you can, similarly how he was able to incorporate images of the place, you could actually incorporate images of your surrounding, and allow that to increase or decrease, your desire for this thing, if it is worth adding that extra 2 mil or whatever, or more to the value of the property, based on the fact that it has a nice scenery, etc. So yes, you can edit the solutions accordingly, correct?
Um, you can't. I mean, I did actually play around with that. So what I used was like satellite imagery from like the community to kind of like figure out like it's like a lower high income area. But I just got income data from Mona Geoinformatics. Shout out to Mona Geoinformatics. So I just used that instead, and that was like a much better predictor than anything else. Um, I see another question from Jeff. There is an iteration on the image evaluation prompts. Yeah, so like I mentioned, I did like actually have two variables. I was trying to figure out like which one performed better. I had luxury level and actually had home tier. So like home tier only has like three potential values, which is like low end, mid range, or luxury. So it's like much lower granularity, but like luxury level is like 1 to 10. It's numeric instead of uh like a classification kind of. So I found that luxury level performed much better than home tier. So I kind of just shelved it afterwards. So that's kind of an iteration. I think I mentioned that in the article, I believe. And you can actually see the correlation here. Let's see the correlation for home tier. It's not here. I didn't convert it to a numeric feature. But from what I remember from doing that, it was not good. Oh, I'll say here's coastal distance, which is what kind of relates to what somebody else asked. And it does, so like you do see like a negative relationship between coastal distance and price, which is what you kind of expect. So this accounts for like touristy homes. So like you have like a negative correlation. So homes that are farther from the beach would be priced a bit lower, but the signal is not enough for me to it wasn't enough for me to keep it in there, unfortunately. But it was a good idea. So you're on the right track.
Okay. Are we having any questions on YouTube? So we currently are streaming on YouTube, so we do expect to have some audience over there. Jordan, any questions from that side?
I'm
Not Jordan, sorry, Jason. I don't think you'll be able to see it, Jordan. Jason. Okay, so
And if
no.
if there are any questions, I did post a link to an article I wrote with the same like subject matter. So if you do prefer like to read, uh you could either leave a comment on the article or you could read it and see if maybe it answers it because it might go into a bit in some ways, some ways not.
Okay. Great. So currently we don't have any questions on that side. So I'm gonna just switch back over and start to share again. So very insightful solution that you've provided to us. I definitely want to encourage the team to play around with it and to maybe even see how you could incorporate it with other situations. Maybe not necessarily cars, because we do have that bias against Toyota. Is it Toyota or Honda? Whichever. I, I don't have that bias, so I don't really too care for the name of the car in terms of brand. But so there are some situations that do affect persons' choice on homes, similar to cars, and we can definitely see how this solution can be applied in other areas. So yeah, great. So given that we have no further questions, we'll be moving on to the remainder of the session. Right. So this is our past event. If it is that you missed it, it was a great session we had with the host, the CEO for um Intellibus. It was very informative, and it gave persons an opportunity to ask him direct questions, etc., and to just find out what was his thinking, how did he arrive here, what is the plan going forward, and for those who participated in his hackathon, I'm pretty sure you guys had a wonderful time. So yeah, we had a session with him. If it is that you missed it, you can always check it out. We have our recordings on YouTube. I'm gonna ask either O'Shane or Jason to just drop that in the chat for those persons who don't have it. And of course, we also have a recording for creating that idea, moving from idea to an app. We definitely want to encourage persons, because we do have various people with varying solutions. Solving the problems. Using their skills to make an impact. So we definitely want to encourage you to even take it further. If it is that you can have your solution in an app, by all means check out our event that has passed. Another set of things that we've posted is our company that we've done events with before, all the way outside of Jamaica. They're in the Caribbean. I believe they're in St. Lucia. They actually were looking for persons to join their team, and they had a virtual job fair. So if it is, unfortunately, it has closed, but if it is that you want to keep abreast of any of our events, any of our activities that we have from time to time, please do join our community and be a part of the Telegram group. We post all this information. So, if it was that you wanted to, speak directly to the CEO for Intellibus, yeah, it would have been great to get it live and direct, and ask whatever specific question you have. But of course, you can always check it out online for the rebroadcast. And of course, for upcoming events, we do have our senior dev connect. That's going to be a physical event coming up. We want to encourage you guys to work on your portfolio, because this is going to be a great opportunity to interact with some international experts. They're going to be on site physically with us. There's going to be limited space available. As soon as we're given the go ahead to give you a more information on it in terms of the venue, and have the registration open, definitely going to do that. But yes, look out for that event. It's coming up soon. As I said before, prepare your portfolios. And of course, part of being in tech, part of being problem solvers, we want to, of course, get information. And this is one of our surveys that we have currently going on, because we want to have an idea of what's the cost of living like, what's going on in Jamaica, and we definitely want to understand that information. We've done salary surveys before, and this is one more of our surveys that we carry out, so that we can analyze the information, and maybe, who knows, put it in an AI and maybe make some predictions. So yes, please fill out our survey. It also gives you an opportunity to let your voice be heard. Don't worry, it's completely anonymous. We don't have any, we're not using any information to identify anyone in any of our surveys. So please feel free to participate. All right. Now, if it is that you want to participate in our future demos, we're gonna have be having some workshops. We're gonna be having career days, etc. Feel free to send us an email at community@caribbean.dev. So this is the email that's displayed on the screen. Feel free to reach out to us. We definitely want to hear from you, whether it is that there's some recommendation that you have, maybe there's an opportunity where you'd like to volunteer with and work with us to help sharpen your skills and your experience. Feel free to communicate with us. We definitely want to hear from you. And of course, this is simply, it's an outdated slide, but if it is that you want to keep abreast of some of the information that we'll be sharing, please feel free to be a part of our meetup group. Feel free to be a part of our meetup group, right? This will allow you to be able to stay abreast of our upcoming events. We're going to be announcing them on this platform. So, stay connected to us so that we can keep everyone, on in the know as what it is that we're going to be having as we progress throughout the year. So, yes. Now, this is where we're going to be, closing down, winding down. It has been fun. We definitely want to thank our sponsors. We do have merch that's going to be allowing the community members to buy. So yeah, there's some information posted in the chat. You can always reach out to us. We definitely want to thank you guys for attending. Want to thank you or guests for sharing that knowledge and using the tool to solve a relevant problem that each and every one of us have as it relates to home ownership. Because as the prices continue to go up, we want to make sure that we're getting value for our money. you know so yeah, definitely glad to have each and every one of you guys. If it is that you want to contact us, this is how you can contact us. Or events and our training, etc., as I said before, it's going to be on meetup, but you can always email us. This is another email you can reach out to us via emails at jamaicans.dev. All right, so with that being said, have a great evening, and I look forward to seeing you at our next event. All right, have a great evening. Bye.